How's it going, everybody? Who's getting the first comment award this week? Everybody, another minute to shuffle through. Hey. Oh. We're ready to get started in just a few more seconds here. See if anybody else is showing. All right. Well, let's kick it off. Well, welcome everybody to week 7 of OpenTofu Foundations. Today we're going to talk about managing multi-environment deployments. This is kind of the first place where we're no longer kind of making a toy. We're no longer making like a hello world. We're actually talking about like how to use OpenTofu in the real world. And before we do that, like I want to get into a little bit of like why we use these tools, because we really haven't covered that all that much. So let's take like a quick trip in the technology time machine here and talk about like how we ended up with these kind of declarative tools to manage system states. And we can talk about like what that means and move forward from there. So the story kind of starts in 1993. Mark Burgess is running a physics lab, and he has to manage a bunch of computer systems of different flavors of Unix, right? And he found that a ton of his time was spent kind of like manually scripting stuff on each individual workstation, dealing with like individual problems in different, versions of Unix. And what he needed was some kind of a tool that would allow him to kind of declare the state of a system and then let the specifics of that flavor of Unix work themselves out. This led Mark to create the CF engine, which got its first release in 1993. So this was a really good way to like manage workstations for a long time. And then we fast forward a little bit to 2009. Chef is created. It gets its first release, right? And Chef is like really interesting because it takes the concept of CF engine, it creates like a declarative DSL, gives you the power of Ruby behind all of that, and it's got a client server model, right, which allows you to like have a fleet of like VMs that can now reach home and say what state am I supposed to be in, and it will automatically update. This is not a coincidence. EC2 becomes publicly available in 2006. So people are struggling with those problems of like managing, fleets of servers, right? And in 2006, we were still doing, hardcore 3-tier web architectures, right? We had load balancers with, horizontally scaling servers. So this is like a really useful kind of extension and evolution of that initial kind of CF engine invention, right? As we kind of go down the line further, Terraform and Lambda are both released in 2014, just like separated by just a few months, right? And that's where like the kind of like cloud native approach is starting to really be solidified, right? These cloud providers are starting to get bigger. They're starting to provide more services with like their smarts kind of internalized. And we needed something to treat our cloud native deployments the same way that we would like a server, right? We now have kind of Linux systems administration problems in the cloud now, right? So things like IAC, right? Terraform, now OpenTofu, Pulumi comes out, right? All of these things become a lot more useful because there's so many buttons to click in the console now. So this is kind of like a trend that is only going on. It's only becoming more complex, right? And the tooling and the way that we use the tooling needs to evolve with it, right? And so that's what we're going to kind of cover today is like, how do we start to manage this stuff in the real world? What strategies can we employ to actually like manage our production deployments and staging deployments and dev deployments and multi-region deployments and all of these kind of like real world use cases that like just doing an OpenTofu tutorial can't really teach you. So to kind of sum up everything we just got at, clicking the tool that the clouds give you, right, the console, leads to a lot of user error, right? Are you going to remember when you need to spin up, a deployment in another region because of an outage in your original region? Are you going to remember every button you clicked, every policy you created, every little change that happened? It might have been years or months between when you made the first environment to the second environment. And the answer to that is no, right? The cloud gives us the ability to kind of ephemerally build stuff, and it's not hardware we own anymore, right? So we need the tools to be able to replicate and stamp out our infrastructure deployments over and over and over, right? That's really the power of the cloud. And if we're not harnessing that, we're actually not getting the most value out of the cloud. So let's dive into like OpenTofu. Let's dive into like how we can start to like treat our infrastructure in the cloud as things we stamp out versus like a thing we own. And so the first thing we're going to do, we're going to check out the week 7 branch from Git. This is going to have all of the code we're going to write today. If you're following along, you can go to week 5 and make these changes there, and then check out the week 7 to compare. But let's start with the first thing we always do. Let's tofu init. Now, in week 5, we set up a backend that was in S3. So all of this kind of depends on you still having that backend set up. Sorry, let me close this. So we've tofu init. Let's go ahead and do tofu workspace list. Now, OpenTofu workspaces are a mechanism that allows you to have discrete backends or discrete state files, more specifically, per environment, right? So we are in the workspace that is always there. Anytime you're using OpenTofu, there is a workspace. It is the default workspace. That's the workspace you were working in week 5. If we do tofu plan, var file, default, auto tf vars, let me just wait here. You'll see it's refreshing. Again, you'll see I don't have any state files locally. All of these are in. I made some changes. Sorry, jumping the gun a little bit here. We run that plan again. You should see it actually plans. There we go, and you'll see there's some user data, but it's not going to make any large changes, right? This is mostly exactly what we deployed last week, right? Using that state file. So let's create our first workspace. Let's just say we want to make a staging environment for our WordPress instance. So the first thing we're going to do is we're going to say tofu workspace new, and then we give it a name. So our name here is going to be staging. You'll see we're creating a new workspace, and you'll see we've created it and we've switched to it, right? So now if I do tofu workspace list, waiting on this. You'll see we have default and now the stars next to staging because that's what we're on. So let's do a plan here. Tofu plan, and we're going to use the same var file. Is default. All right, and you'll see we have a plan, and it's a lot of stuff to add. This means there's nothing in a state file backing staging, right? And actually, the state file doesn't exist yet. This is kind of proof that we're actually working in a new workspace. We have a different state file in the back end there. But looking through our plan, we're going to notice that we have some problems, right? One, look at our naming. Week 5 query instance LT, right? All of these naming conventions will cause OpenTofu to fail when we actually apply it, right? So we need some way of passing different variables into our OpenTofu. And so what we can do is we can create a new file. So we do touch staging.auto.tf vars. We're going to use the same convention we were using before. There we go. And we're going to echo that same var file. 7 Dave. We'll change that. And we will put it in our staging auto tf vars file, right? So now you'll see we have a new vars file with a new name prefix. So in working with our new file, we can change that var file name to staging.auto.tf vars. Now, if we run this plan, we'll see that our name has changed. All right, we're adding a bunch of stuff again. And you can see we've got the new name prefix in, which is great. This will theoretically run. But we have some problems now, right? One is like, look at our tags all, environment dev. That no longer actually reflects reality. We're actually deploying staging. So we want to be able to make these tags right. And it probably makes some sense to keep the same name prefix because that's likely like your project name or something, but actually just add in an environment. So let's start doing that. We're going to go into our main.tf here. And we need to change this based on the workspace we're in. How will we do that? Well, let's create a new locals block. And let's do environment equals. And we're going to do a ternary here. So we can do terraform.workspace. This is a variable that you have access to. It will automatically inject the workspace you're into. If you only have one workspace and it's default, this will always be default. Because we're using 2, it will actually change. So we're going to say if it equals default, we want to do something different, right? We want to keep the value that we had before, which was dev, not default. So we're going to say return dev. Otherwise, we're going to return terraform.workspace, which in this case will be staging. Now we can come down here to our environment and say environment. Awesome. Let's see what that did to our plan here. All right, we got a plan. Let's look at that tags all resource again. And look at that, environment equals staging. If we swap back, by doing Terraform workspace select default, and we plan with our default auto.tf vars, we should see that same clean plan. Yep, same plan. Okay, so we're backwards compatible, which is great. So now if we go back to our workspace, let's deal with the swapping the name prefix back in our staging. How would we solve that problem? So if I go into my staging auto TF bars, we'll call it week 5 Corey again. So we need to solve this naming collision problem. And to do that, what probably makes sense is in the name prefix here, right, adding something like staging, right? Now, the issue we're going to run into is because our dev environment is already deployed and because changing things like names will cause a delete and recreate, we actually have to come up with a strategy here to make it so the default workspace, nothing changes. But in subsequent environments, we actually can put the name segment there. So what we can do is define another local. And in this local, we can call it like env name. Let's be verbose. It always makes sense. So in the default case, we're going to say add nothing, right? This will make the default workspace continue to work exactly the same. Won't force delete and recreate. In the event that we have, we're in another environment, we need this like name segment, right? And it has to be your environment dash to keep with what we have here. So we're going to do Terraform workspace dash, right? And so this will allow us to make a name segment. Let's come in here. Everywhere we need a name segment, you can actually do local dot environment. Did I say neg? Oops, I didn't mean prefix. I meant segment. Environment name segment, right? And so this will end up being week 5 Corey staging PB. Similarly, we can come down here for this instance and we can say the same thing. Local dot environment. Name segment. And this will do the same thing for our AWS instance. So let us validate that that actually worked. So we'll plan our staging because we're in staging now. All right, let's take a look. Where is this? So you can see here, tag specs, week 5 Corey staging instance, right? So the name looks exactly how we want to. Let's verify that tags all still says staging. Awesome. And now let's, because we made changes, let's swap back to default. And just validate that that ternary is actually doing what we expect. So we should see the tags all being the same. We should see that same clean plan to ensure we're backwards compatible. Awesome. Same clean. So we're swapping back yet again. We're going to staging, and now we're actually going to apply out the changes we made. All right, so we are in workspace staging. We are going to do apply with the staging auto TFRs. And we'll just wait a minute for this to deploy out. So again, we should run into no naming conventions. This should all be deployed. We're going to say yes. Now we live the life of operations where we just wait for things to spin up on the cloud. In the meantime, what we're going to start to cover is like, where's the state file, right? We know it's in S3, but like, what does it mean to be working in workspaces here, and where is that state? So if I switch over to my AWS account here, you'll see this is the state bucket that we created in week 5, right? You have your original state file here that was managed in default. If I refresh here, we see a new directory, right? And it's env:. Env: is a environment prefix. You can actually override this in the settings for your backend. I didn't, because it doesn't matter. It wasn't like a name prefix I cared about, but this is configurable. But within env, you'll see we have our workspace name, right? So we're creating that directory structure. It's the prefix for workspaces in general, which again can be defined. Your workspace name. And now we have the key that we set, right? The key we set for this was WordPress/tf state. So here is kind of that beginning of that path. And there is our tf state. This is what workspaces manage for you. They create prefixes for where you store your backend. I think locally you need to set paths, I believe. But with the S3 backend, this is all kind of taken care of for you. But now you can see we have discrete state, which means we can destroy this and it doesn't affect default, and vice versa. Let's go back into some code here. We're still waiting on those EC2s. I think this is a good place to kind of stop and say, like, are there any questions about like what we've covered so far, how you switch between workspaces, and what that kind of means? No, we're all clear. Everybody's caught up. Good, because we're going to go to production, and this is where things get fun as soon as this runs. Did not expect this to take as long as it is. All right, so we can get into some theories. So what we're going to have to do to create production is exactly what we did to create staging. However, our production workloads probably aren't using T2 micros, right? We're going to need some way to configure our OpenTofu configuration so that we can say staging gets this, but production gets this. And so because we have those var files, it becomes really easy, but we do have to make some changes to main.tf in order to support that. So we can start doing that now in main.tf here. So what we're going to need is a couple of new variables to start. And our variable declarations are down here. Let's keep all of that stuff together. Perfect. You'll see everything went out and we have a public IP address. So the first thing we're going to want to do is define a variable, which will be the WordPress instance type, right? Which is defaulted right now, but we will want to be able to change that. We'll also need a DB instance class, and that will also be of type string. Now we'll need to make some changes here. So our AWS instance DB instance module has a instance class attribute, and we can set that to var.db instance class. And similarly for our AWS instance, we can say instance type equals var dot instance type. Nice and easy. So now if we let's do this. Let's just verify we're still in staging before we run this. We sure are. Oops. Should be a dot there instead of a dash. And as you can see here, we have missing variables, right? So let us go back into our staging and let's say WordPress instance type. And it's just the T2 micro, and DB instance class is a DB-T3 micro. Now we'll plan again. And what we should see is there's nothing to change. All of this is now backwards compatible. We're just kind of opening up a way to configure the stuff we care about between our two environments here. And again, very similar plan. I think this always updates in place. So for all intents and purposes, the plan is clean. And now we can do the same for default. But again, because we're managing environments, it's very important to tofu workspace select default and just double check that none of the changes we've made have affected our kind of previous environments. We are switched to default, and now we can plan again. So this question, yes, it manages the locks separately as well, I believe. Yeah, because your state is in different places, two people could. But again, I don't necessarily recommend two people on their computers doing that, right? We should have some pipelines. And we're going to kind of get into like some automation because as you can see, this is already a huge pain. Okay, clean plan again. Awesome. That means we have two environments, both of which are in a state that, you know, makes sense for us. So tofu workspace new, and we'll call this one production. We are switch to it. We'll go through this to show list. We now have three environments: default, production, and staging. This is very common for production applications, right? Having somewhere to kind of test, somewhere to like actually test production changes before they go out, and then a production to promote to. We're going to need a variable file. So let's do touch production.auto.tf bars. And we're literally going to copy and paste all of the same things, right? The content must be the same, but we're actually going to use a T3 micro here for the WordPress instance type. I'm not going to deploy this out, but let's just plan it and show that that's what would happen. I don't want to subject you to another one of those. Production.auto.tf vars. And if we go to our instance type, you can see we're doing a T3 micro instead of a T2 micro. So we have all of the foundation laid to basically treat our OpenTofu code as a blueprint where we can actually stamp this out multiple times in multiple places and keep it in parity, right? One of the scary things, though, is you can see that like changes to this require you to actually go back and make sure like there's backwards compatibility and things like that. And like that's unfortunately something you're not going to escape when dealing with workspaces. So let's do something to make sure that we lower the risk of user error when doing this stuff, right? So it's like we want to make sure that somebody's not in the wrong workspace using the production var file and destroying something or deleting and recreating something, right? We want to make sure that, like, if you want to get rid of your dev environment because you're not really using it all that much, let's make sure that we're not actually pointing to production, right? So let's just work through like what that might look like. And to do this, my favorite tool is actually make for things like this. So we're going to make a make file and we're going to populate it with some commands, right? And so just so you don't have to watch me type too much, we're gonna look at, I have the make file already built. So you'll see there's 6 commands in this make file kind of by default, right? There's environment plan, right? And there's 3 environments, so default, prod, and staging. You'll see that there's staging.deploy, prod.deploy, and default.deploy. And to start with, you probably shouldn't have any of this, right? You should probably start with your simplest set of commands, right? Which is select the appropriate workspace and do a plan using the appropriate TF bars. So we're just going to get rid of this for now so you can kind of see what that looks like. If I come in here and I do tofu workspace list, you'll see that we're still in production. And if I do make default.plan, you'll see we've selected the appropriate workspace and we're going to apply the plan with the appropriate set of bar files, right? This is super helpful to make sure that you don't make like just basic mistakes, right? It also is kind of the start to automation, right? If you want pipelines and you're not managing 6 bash scripts, or you don't want to manage 6 GitHub Actions pipelines, right? Being able to kind of tap into this make file and use basic conditional logic on input to make sure that you're doing the right thing is really, really valuable. And again, they just need to be really, really basic to start with, right? Make sure you can apply and plan with the appropriate var files to make sure you don't delete an environment you didn't mean to. Any questions there? We're going to move on to governance in a minute. So I just want to like make sure everybody's cool on like why we're using make, why this is better for end users and probably yourself. I've seen that mistake made a lot of times where people accidentally delete production. Awesome, we're good. Cool. So the next kind of topic is we're managing multiple environments. That means governance, right? We have this like blueprint stamper. We have the ability to like change variables, right? So we could theoretically run WordPress on Graviton if we wanted to, which is probably not great. We need some way of making sure that all of our resources that we're deploying are compliant, right? So we want to make sure they're secure. We shouldn't just be putting anything into production. And then we should also be able to run some checks to make sure that like people aren't doing things like using Graviton instances, right? So to do this, we're going to take a look at a tool called Checkov. Checkov is an open source tool which will run a bunch of security checks against an OpenTofu plan. And it'll give you a readout of like what common security policies you're violating. And then later, we're actually going to make our own policy to say we have guidelines that we use in different environments, and we're going to actually modify these pipelines to effectively manage that. So let's take a look at Checkov. If you're using the dev container for week 6, everything's set up for you. Because this is a Python package and APK does not have Checkov prepackaged, you will, in order to use this, need to do ./vm/bin/activate so that you can actually use Checkov installed in your virtual environment. But if we do Checkov-H, we will see that this is currently installed. Lots and lots and lots of options. We're going to do kind of like a simple overview of this. So there's lots of ways to run Chekhov. It can do pure static analysis. It can just kind of like look at your Terraform or your OpenTofu or your Helm or your cloud formation. It works on lots of different IAC, but it can do a static analysis of what you have written, which is fine. But the problem is if you have like a conditional that lets people set something up one way or not another, not having those variables included makes it less effective. So how we're going to run this is we're going to generate JSON plans, and we're actually going to run Chekhov against our JSON plan. So we are in production here. So let's start. Let me check that. We should be in production. If we're not, we're going to be in production. So we should modify our production plan to actually run this check. So we are in default. That would have been bad. Awesome. We're in production now. So let's just run the commands as we see here, and we'll backport them, or you'll backport them if you're looking at a makefile that is empty. But we do tofu plan. We're going to use that production var file, and we're going to set the out flag to say we want the plan to go to a file called production.plan. We're going to run this, and you'll see plan run. I don't remember if the output comes out. We're going to find out. Yeah, we still get to see the plan, which is great, but you'll see plan was saved to production.plan. So we have to run an intermediary step here to convert that plan to something usable like Chekhov. So we're going to do tofu show JSON. We're going to use that production plan, and we're going to create a production.json file. Awesome. Now the magic. We are going to pass production JSON into Chekhov, and we're going to see what it produces. Look at that. Lots of failures. Unsurprising. We're using a lot of stuff. Like we're using the default VPC, right? We're not doing things like deletion protection on our instances, right? Because again, we were dealing with toys. Now, before we go to production, it makes a lot of sense to make sure every one of these checks pass. But for now, we're going to kind of leave this as it is. But your goal should always be to make sure these checks are clean. Now, in staging, is it as big a deal? I think some of these might be. You could make arguments, but we're probably not, snapshotting our instance in staging, right? Definitely not in dev, where it really is truly ephemeral. So let's talk about how we can kind of like modify a plan so that like we can actually just skip some of these checks, so we don't keep getting it failing, and we're like, this is good enough for our purposes. So to do that, we're going to do the same thing in default. So we're going to say default. We're going to do our plan there, right? We have to do our conversion from the plan file to JSON. But our command here is going to change. We're still going to run Chekhov F default JSON, but now we're going to use the skip check flag to say, here are the list of things that are going to fail that we're absolutely just not going to use. Let us make that look a little cleaner. And then finally, we're going to clean up after ourselves. All right. Now, we don't have the headache of having to figure out whether or not we are in the appropriate workspace, because now we can do make default.plan. Unsure. I know Bridge Crew was before they got acquired. They had a bunch of custom stuff too. But yeah, I couldn't tell you about Manta. Oh, awesome. This is great. I will definitely check this out. I didn't even know this existed. All right, and there you go. Lots and lots of green, right? We've decided that this is sufficient for dev. Now, any questions before we move on? Because what we're going to do next is create our own policy to make sure that in staging, you can never deploy out anything bigger than a T2 micro. Nope. All right, cool. Let's get into it. So staging is the place where this may be the biggest risk. So we will add this explicitly to staging. But see here, we're going to say our WordPress instance is going to be of type T3 micro, right? Which is bigger than a T2 micro. This should fail, right? If we're trying to govern and make sure that people changing the inputs to these workspaces are actually following guidelines. So the first thing we're going to do is create a custom policy. To do that, we're going to do touch preprod policy.yaml. And we have our YAML file here. And I'm just going to paste in from the README. So your custom policies in Chekhov consist of two sections, right? One is a metadata section with an ID. So you see here, your check has an ID. You're going to give it a friendly name, right? So we're going to ensure that instances are of T2 micro. You have to give a category. There's a limited number of categories. So we're just going to call this a convention. And we'll give it a high severity. This could, this is probably not actually high severity unless like you're really trying to cut costs in your cloud. And so for the second section here, we have a definition, right? And you have a condition type, right? There's lots of different condition types. We're going to do attribute. So what we're saying is somewhere in our OpenTofu, there is an attribute that we want to run a check against. And you give it the resource types. So you're going to look at all AWS instances within our OpenTofu. The attribute on AWS instance will be instance type. Operator, self-explanatory. We're going to do equals in this case. And we're going to give a value of t2.micro. So now we will save this. We will go back to our make file. And in staging, you'll see that we've added a couple of extra fields to our Chekhov run. So one, I said soft fail. I don't want Chekhov to give me an exit code necessarily. That's just purely for cleaning up our outputs when we run this. You will want hard fail, especially if you're running this before deploying. We're giving it an external checkster, which just means like I've written some custom checks that Chekhov doesn't necessarily know about. We're going to define it here. You should probably have a directory. You can also set it to like a GitHub repository to keep all of these checks. Yeah, I mean, it could be. Richard, do you want to take that? And I'll continue on while you do that. Run all external checks here is just telling Chekhov which checks to run. So we want to include all of our external checks. You can also tell Chekhov instead of skip, you can tell him like only run these, only run this this category. In this case, though, we're just saying run all external checks. So we are going to do make staging.plan. We're switching to that workspace again. This is already so much better than having to worry about whether or not I'm doing this in the right workspace. And for some reason, that passed when it absolutely should not have. Looks like I have a problem with the formatting of my policy. Oh. Let's debug this real quick. I'm going to actually do in folder policies. Let's move that. I think there was some stuff in the environment that I didn't expect. We'll go back into our make file here. External checks directory will be /policies. And let's try and run this again. Let me also verify that I changed that. Yeah, I did. A comment bubble. Is there still a comment on the screen? I don't see it. Is that gone now? Okay, so instance type in the plan, it says it's going to T3. And it passed again. Unsure why it's failing, but I do want to get into some other stuff. But this is kind of the anatomy of how you would set this up. Still unsure why. That value is definitely not equal. Well, I'll put in the I'll put in the challenges to get this pre-prod policy to actually run. But that's how you can do it, right? If you want to do this at kind of deployment level, checkoff is really, really powerful for this, and you can really kind of like hone in what matters to you and your security team when dealing with kind of multi-environment. Obviously, staging is usually much more permissive than production, so this is like a really valuable tool. Any questions before we move off of kind of checkoff and how you might use it? We're good? All right. So the thing I want to talk about now that we've kind of seen how you might manage IAC like this in the wild, like in your business, I want to talk about the fact that this is still not really enough. We don't really live in a world anymore where like we're dealing with like 3 WordPress instances in prod. Like, yes, sometimes, but not always, right? And not for the most part, right? We're dealing with lambdas and databases and all that kind of stuff. So I want to talk about like some of the decisions that like my co-founders and I have made about like how to best run Terraform. And I don't want this to be like a shameless plug, but like we now deal with this world where we have to deal with like feature branch environments. We have to deal with multi-region deployments, which each have their own environments, right? We have to deal with like microservices where people are, releasing lots and lots and lots of infrastructure deployments to meet demands of the business, right? And there's just so much more to do. And that's where we kind of border into like platform engineering, right? At some point, you need some kind of a brain to help you manage this stuff. And as you can see, workspaces are pretty cumbersome. Like 4, 5, 6 environments start to become difficult, right? Having to, make little shifts in conditional logic to make sure that like you get an extra S3 bucket over here, but it only has these IAM permissions in these environments. Your Terraform and your OpenTofu can start to get really difficult. So some of the decisions that we've made about how to manage this, I want to get into, but let me answer this question real quick. General question: what is your preference on dealing with different versions of TF code? Aha. Okay. So I don't think prod being behind dev 3 commits is not good, right? We want parity as much as humanly possible. We want to ship those things constantly. Prod should be 1 commit behind dev, right? Like when you think about like, or 1 release, right? I could see you maybe making some commits to test something. But once you get to that final version, like that's releasable. That should immediately go to staging, and that should immediately go to production. So I think being behind a little bit is okay, but like you need to like promote as fast as humanly possible. Yeah, commit tags really, really useful. Even SHA numbers are useful in like managing some of that. But workspaces do kind of fall apart, right, without the Git checkout aspect of that. So that's kind of what we're going to get into next. So one of the things that like becomes a reality when working with infrastructure at any kind of scale and working with like OpenTofu and IAC in general is like people now have the access and the ability to like stamp out lots and lots and lots of infrastructure, right? So it becomes more imperative that your IAC is a blueprint and not like the configuration for a living thing, right? It has to be more of a stamp than it is like the actual concrete implementation of something, right? And that comes with like another difficulty, which is like you can't shoulder surf people anymore, right? So you need some way of like publishing these blueprints and then making them accessible so that you're not tied up every time anybody wants to do stuff. And I'm going to pull up Mass Driver here because one of the things that we had to do was like figure out how to answer that question of blueprints, right? How do you publish a blueprint and make it accessible to everybody without having to write a bunch of Terraform, right? And so you'll see here on our left-hand bar, there's just a lot of these little boxes. And all these boxes are like Terraform modules that we allow people to grab. And they're blueprints. They're blueprints that people can run over and over and over to stamp out as many things as they want. So you could see that application in something like ephemeral on-demand environments, right? You could see that use in something like quickly spinning up a disaster recovery environment because US East 1 is down, right? You could see that in like expansion to Europe and things like that, managing these things vertically and horizontally, right? Without you, the operations professional, having to like modify your code every single time for every single use case, right? The next thing we kind of want to do away with is like the management of these VAR files, right? Having duplicate VAR files with subtle changes that we have to like manage the differences between is really, really cumbersome when you're trying to get infrastructure deployments out. So if I pull on like this DynamoDB table and I give it a name here, we just call it Dynamo because we're incredibly creative. We will add this to our canvas and you'll see here I have a little box. And when I click this, these are all of my variables for this module presented as a form. And this works because OpenTofu, Terraform, all of these major IAC providers allow you to talk to it via JSON, right? Which means we can build a JSON schema, submit a JSON form, and the results of this form are stored in a database and become those input variables, right? They're stored in context, and I, as an operations professional, don't need to watch them get committed and do all these things. So if we kind of come over here, we'll just select a preset. We'll drop this capacity down a bunch. Read capacity 1, write capacity 1. And we'll just save our configuration there. So now we've essentially created a VAR file, right, that we just don't even have to think about, right? Doesn't matter how you do this, getting out of that game as soon as you kind of hit scale with IAC is really, really important. And JSON is your best friend. It's really easy to store. Most programming languages speak it. So if you wanted some kind of like basic app to manage your state because GitOps is not the ideal choice for you, JSON is your best friend in kind of that battle to get out of managing that configuration at the workspace level, right? The next thing we have to do to like really optimize this whole situation is like, you saw me make a target for each environment, right? Both plan and deploy, right? That's your CI/CD pipeline. It's just getting bigger and bigger and bigger as you go, right? And so one of the decisions we had to make was we needed to create reusable pipelines. So OpenTofu is the same process every single time, right? We say, I need to deploy something. It needs to use these variables, and I want you to run all of your security screening against it. So if we click the deploy button here, you'll see I haven't done anything to configure any special pipelines or anything like that. All I've said is, hey, platform, I need you to run OpenTofu, and I need you to do that with these variables. And we've sent that request off, and the kind of reusable pipeline is saying, like, I know what to do with OpenTofu, right? And you'll see here, we've done a init. We're going to keep going here. We've finished in it. I think we're going to run Chekhov next. We're going to do a plan. There we go. You can see we're deploying something new. It's telling you everything we're going to do. And you'll see same thing as we had in our make file. We're making a plan. We're going to pass it to Chekhov. We are going to absolutely watch it fail because I did not tune this. You'll see our failures here. And I don't have this set to stop deploy on fail, but like this is just going to go out now and deploy, right? And so this seriously limits my involvement when someone needs a new DynamoDB table, right? The power of that database is kind of handling the relationship between environment and context for us. And this is the kind of software we need around this IAC to actually scale it to the needs of like bigger businesses, right? You know that FANG companies all have this stuff at their disposal. They all built it. But the need for it is creeping backwards into kind of our day-to-day lives in like mid-sized and even smaller businesses. So I'm going to put some challenges to do things like converting your inputs to JSON and stuff like that. But these are kind of like the next frontier for like how to effectively use IAC, right? There needs to be a software ecosystem, and I hope everybody kind of gets involved in like building what is kind of the next iteration of that ecosystem. So that's kind of it for the content. Any follow-up questions, anything like that? Now that I'm off my soapbox. No? Well, awesome. Thank you, everybody, for joining us. If you have any questions or you think of anything after, the community Slack is there, so feel free to post there. Yeah, and thanks for joining us.